Hello, so I'm going to quickly go through the three main questions that we're supposed to answer as a part of our, I guess like the rubric for our model. So the question that my model seeks to answer is how the population of native fish is going to change once an invasive species is going to introduced into the ecosystem, and then we also want to know how the water quality is going to be affected once that invasive species is introduced. I believe my model does answer these questions, as we could see how the various um, I guess we could see how the population of native fish is affected when there's a lot of invasive fish introduced, when there's a little bit of invasive fish introduced, or small number versus large number of invasive fish introduced, and then we could also see how it is affected when the invasive fish have a range of reproduction rate, and that also goes for the reproduction rate of native fish. My model also reports water quality, that which is directly affected by the number of aquatic plants and the proportion of native fish that are still left in the overall population of fish. And then the one pattern we are looking for here is that as the population of native fish increase, we expect the population, as the population of invasive fish increase, we expect the population of native fish to decrease. And we could see that. So over here, these are like my standard settings. So once someone were to open my model, this is what all of these sliders are going to be set to. So we expect them to be a small number of native fish. A small number of invasive fish, while there is a large number of native fish still in the population, and is about 150 plants. I just thought that was a good number for all of these fish to survive off of. And the native fish have a reproduction rate of 5%, while invasive fish have a reproduction rate of 7%, just because invasive fish, usually when they're introduced into an environment, they are labeled as invasive fish because they have almost like an advantage in the ecosystem, and because of that, we expect them to reproduce more easily, which is why they have a slightly higher reproduction rate. And as you can see, as we run the model, the invasive fish, we get the user message that the invasive fish have taken over. So we are proven right that as the number of invasive fish increases, the number of native fish decreases. And that pattern is found in my model. In my model, there are three types of entities: native fish, invasive fish, and aquatic plants. And all of these are needed in order to answer my model's big question of how native fish are affected when invasive fish are introduced and how water quality is changed. And as you can see, those three entities are represented as different breeds in my model, just because I thought that would really help facilitate using those model within these procedures. I believe that each variable in my model is easily understandable, especially the entities, because they have very specific shapes. As you could see, the native fish are black and they're a little bit smaller, while the invasive fish, we're only 10, so those are just the red ones, and they're slightly bigger. And then the aquatic plants have these cute little plant shapes as well. The fish both have fish shapes, which I thought would be cute. And then the patches were turned into the color blue, just because I thought that would just really represent the true look of, I guess, a pond or a lake where we would find these fish. And I think because of that, the shapes and the colors, it makes the model very easily understandable, and all the variables in it easily understandable. The only variables that are a little bit slightly complicated are how I decided to calculate the number of aquatic plants and water quality. So that's mostly over here. So like I said earlier, we start with 150, but then when in this submodel, update number of plants, we're taking into consideration the proportion of native fish, which is just what it sounds like, the proportion of native fish in the overall population. And then if a random float is greater than that proportion of native fish, we're going to ask one of the plants to die. So if the proportion of native fish stays high, then we expect for there not to be that many plants that are dying. But if the proportion of native fish is very low, then we're going to have a lot of plants dying. And then we're going to set our water quality to be the proportion of native, which we calculated up here, times the number of plants. And then this procedure is called once every tick, as we see over here in the to-go function when we ask plants to run that function. And then for number 4, so the first, just going through the submodels in my model and how they run. The first one we run is to set up, and that creates the number of initial fish, or initial native and initial invasive, and that, as you can see, is set up over here in the interface tab. And like I said, these are the set to be 110, but those could change. And then we're also going to set those shapes: fish for the native and invasive, and then their color: black for native, red for invasive. And then, like I said earlier, invasive are slightly bigger than the native fish, and both of those are just randomly placed anywhere in the plot, or I'm sorry, the view, the model over here that we have. And then I'm also creating the initial number of plants, which is also set in the interface tab right here. Right now I have it at 150, and then that's giving it the shape plants, color green, and then the size 2.5. And that's also going to be randomly scattered in the plot, so every time I press the setup function, they're just randomly placed anywhere. And then to go, that's where we're going to have these user messages outputted based on these conditions. Usually if there's no more natives left, then we're going to say that the invasive fish have taken over and such other things. We're going to ask the plants, like I said, to update the number of plants, and also to update the number of quality. And then we're going to ask native fish and invasive fish both to move, reproduce, and to die, and then to tick. So to move, they're just moving either randomly to the right, randomly to the left, and forward one. To reproduce, they're just making sure that they're following this native reproduce and invasive reproduce that we have set in the interface tab over here. And then the update number of plants, like I've already went through. And to death is just if the water quality is below 0, then the invasive fish are going to die. And if the water quality is below 10, the native fish are going to die. And the native fish dies sooner than the invasive fish, just because they're not used to the environmental changes that are going on when the invasive fish are being introduced. The biggest thing in my model is sensing stochasticity and emergence. Stochasticity is used by determining how we kill off the plants. So as you can see right here, if random flow is less than 1, then the proportion of native fish, one of them will die. It's also used in our reproduction functions for both fish. So if the random flow 100 is less than the invasive reproduction rate, then we're going to either hatch an invasive or a native. Same thing for both of those. So that's how stochasticity is used in my model. Sensing is used because the fish take into consideration the water quality, as I've already explained over here. So that's how sensing is implemented. Initialization, like I said, I've already set the initial number of native fish to be 100, the initial number of invasive fish to be 10, and for there to be 150 aquatic plants. And, those numbers can be changed. My model does not use any input data. I have tested all of my submodels individually, and all of them had expected outcomes and formed the patterns that I expected them to, except for how the native fish are treating the death submodel, just because, as you can see over here, they die very suddenly, and I was expecting them more so to die gradually, since there's only supposed to be one dying every tick. I did test the submodel individually, however, unfortunately, I was just not able to see how to fix this or implement it better into the overall model. I think the interface view does a very good job at seeing how or displaying all the appropriate data that we need in order to understand what's going on. We have the number of native fish, invasive plants, and water quality when the model stops running, and then we also have these plots that show us how those have all changed over time, so we understand the model. And then the model supports sensitivity analysis because we could easily change the initial number of both kinds of fish and their reproduction rates. These design concepts I already talked about, stochasticity and the interaction between the fish a bit, just how as the number of native fish, as the number of invasive fish increases, the number of native fish will decrease. And then for prediction, I haven't really searched based on that, but it basically is just an implicit prediction that obviously the fish don't want to go extinct, so they're going to want to keep reproducing. And then the last part that I was supposed to do is test out the extremes of my model. So right here, like I said, this is the standard that I have set. And when that happens, we see that the native fish go extinct and the invasive fish take over. If we were to set this to something very high, like 15, we have the same outcome. There's something very low. Yeah, so that wasn't low enough, but if we were to set it to something even lower than the native reproduced rate, let's say 3%, we find that the invasive fish still take over just because they die at a much lower water quality. But once we get to about 2%, we do see that the native fish are thriving and they do not go extinct. Yeah, and that will sometimes happen when we're at 3%, but it's most definitely that the invasive fish need to have as low of a reproduction rate as 2% in order for the native fish to certainly thrive. When they have a reproduction rate of 5%, obviously if we were to increase this, then they'd be able to thrive when the invasive fish also have a slightly higher reproduction rate. Like let's say if it was at to 10, but then the native have 16%, that they would also thrive. Sorry, let me set up and go. But yeah, basically in order for our native fish to survive, they do need to be the invasive fish do need to have a slightly smaller reproduction rate than the native fish.